Our group's project was the Gecko news analysis for intelligent trading system. The motivation for our project is threefold. News can dramatically affect stock prices. Traders follow the adage to buy on bad news and sell on good news. Therefore, we thought making a tool which would make the life easier for traders. This tool could also be used by financial companies such as Dow Jones and Bloomberg. Our application listens to financial news related to a company and determines if the news can be classified as good or bad. The application then looks at stock prices for a company and determines whether there is a correlation between the change in price after the news article came out. There are many papers on this topic, but there are few practical implementations of these theoretical concepts. Our application also looks at history and gives users a suggestion if the stock should be bought or not. For our retrieval system, we retrieve the news, current stock price, historical stock prices associated with that, all from Yahoo. We store them into an instance of MongoDB, and we search by symbol. For scoring, we assign score using the PMI, IR, NLTK, and Elasticsearch. We then add weights to news items which are closely related to financial news. We then determine a correlation between the change in stock price and the news article sentiment. Then we check the history and decide if the stock should be bought or not based on the released news article's sentiment. Our solution is novel because while there is no perfect algorithm that can predict the stock prices in the future, our new system is entirely self-sufficient. It can detect when the news article came out and push into the database and mark it as unseen so that the rest of the components can work on it. Our application architecture starts with a source of news articles, which are then parsed for noun phrases and also modeled using a bag of words, which are then entered into our score system. Then the scores are updated into our instance of Mongo database, which also contains stock quotes relating to those articles. We then perform a regression of it to compute the correlation. We then decide, based on the results of the regression, whether to buy the stock or sell the stock. For instance, suppose we have a hypothetical customer, Bob. He is a happy customer. Bob initially starts with $1,000, his current profit, but his earnings have been zero so far through the Gecko system. Our Gecko analysis tool found some stocks using the article analysis about the company that would yield Bob profits if he sold them in the next days. We consider a lot of latest news articles for stock to determine if it's good or bad, and to buy or not buy. Here is a sample instance of our database with various tuples associated by ID, the date, whether or not they have been seen, their associated stock symbol, a number which correlates to the article sentiment, along with a brief description of the headline. Gecko suggested and bought these stocks for Bob's initial $1,000 investment. Garmin, Caterpillar, and Intel below. We then computed the regression of the article sentiment versus its change in price over a brief period of time. For these stocks, we elected to buy because we saw the R value that resulted from our regression was greater than 0.5. We decided not to buy these articles, however, as they resulted in an article that was less than 0.5. 2 days later, Gecko sold these stocks as it knows that the stock prices are higher, as we predicted. Bob made a profit of $2.42 by just considering 3 stocks from Gecko 2 days ago. He could earn much more in just 2 days if he bought more of the same stock or Gecko suggested more stocks. There are further possible extensions we can make in this project. We could also implement a form of support vector regression, which is a machine learning algorithm which is going to predict even more accurate stock prices and prediction. We could also extend our regression analysis tool to use a variable number of days for optimal sales.
How do you get the presentation?